Hi, my name is Matt, and this is a quick video for understanding oil refining, getting the basics of chemistry. Okay, the only two atoms that we're going to focus on here are hydrogen and carbon. This is the periodic table of elements, but don't worry, we're only focusing on these two. And that's because petroleum refineries is where we work with hydrocarbons. And so the word hydrocarbon literally means hydrogen and carbon bonded together. So carbon likes to make 4 bonds. That's the most basic rule that you need to know. And then carbon is represented here by the C, and then each hydrogen is represented by an H, and they form a bond together. So carbon likes to bond with hydrogen or with itself. And this is methane, which is the primary component of natural gas. So for methane, ethane, propane, butane are 4 different hydrocarbons, and they each have 1, 2, 3, and 4 carbons respectively. And as you can see, carbon either bonds to hydrogen or itself. And once you start to get more carbons, they start to make chains. So butane, you can see it's a chain of 4 carbons and then has many bonds to hydrogen. The two properties that I want to highlight are increasing boiling point and increasing energy per volume. So methane is almost exclusively a gas. You've heard of liquefied natural gas. That's very cold temperatures and pressurized. But butane mainly exists as a gas, but if you cool it down and pressurize it a little bit, it will become a liquid. So there's an alternate way to draw these hydrocarbons, because when you get longer chains, it becomes a little bit tedious to have a lot of carbons and hydrogens all over the place. So what people will do is they'll represent it just by kind of lines that are bent. So you can see this would be 1, 2, 3 carbons, and here would be 1, 2, 3, 4 carbons, and it's just understood that it's carbons bonded with hydrogen making up the remaining bonds. Okay, these are more hydrocarbons with more carbons each one, and you can see butane having 4 carbons up to dodecane where it has 12. And I put next to it the boiling points to kind of give a reference. And then here's dodecane. As I mentioned, if you had to draw all those hydrogens, it would get a little bit much faster to draw this line with some crinks in it. And then also for reference, think about water. Water has a boiling point of 212 degrees Fahrenheit, so heptane is going to kind of be the closest behaved to water in terms of when you heat it up, and then octane actually has a higher boiling point. So I don't want you to think that there's only straight chains of hydrocarbons. They can come in all different kinds of varieties. Here's just 3 other ones to give an idea. Isooctane, also called 2,2,4 trimethylpentane, cycloheptane, so kind of connected in a ring, and then 2-methyloctane. So in summary, hydrocarbon is hydrogen and carbon bonded together. Carbon makes 4 bonds, hydrogen makes 1 bond, and as hydrocarbon molecules increase in size, so there's length, the boiling point increases, and then the energy per volume increases. So the purpose of this video is just a very quick introduction, and with this knowledge, we'll be able to build on kind of some more advanced concepts in refining. Thanks.